Hi guys, welcome back. Today I will start a new topic called sequence and series. And in this video, I'm going to explain what sequence actually mean and the type of special sequence we have. So then in the last part of the video, I'm going to explain how you can actually obtain an nth term of a sequence or how to generate a general formula for a sequence. But before I continue, please don't forget to subscribe to my channel if you've not done so. And I've made several videos on different aspects of mathematics, both in English and Yoruba. Thank you. In your primary school, you will have come across what we know as a natural number. When I say natural numbers, they are those numbers denoted by n, so which are the set of counting numbers. So that is those numbers we were exposed to in our primary school. So example, when you have 1, 2, 3, 4, 5 like this. So this is an example of what? So this is an example of natural number. So natural number like this is what? Is an example of a sequence. So when we say a sequence, sequence is an arrangement of numbers that follow a certain pattern or rule. You understand now? So when you have a list of numbers such as the one you are looking on the what? On the screen like this, so that follows a certain rule or patterns, we say such a number is what? Is a sequence. So for example, natural number, we say natural number is a sequence because the rule is that you have to add one to get the next term. You can see when we say term, term are each of the numbers here. So for example, this is my first term, this is my second term, this is my third term, and so on. So you will see that for me to obtain my second term here, what I'm going to do is to what? Is to add one to the first term. You understand now? So the moment you add one to the first term, I'm going to have two. If you want to obtain the next term, you are going to have another one to have three. To obtain next one, you add one to get four. So when you have a kind of arrangement like this that follows a particular pattern, then we say such a number or such set of number is what? Is a sequence. So it's a sequence. There are different types of sequence we have, but the commonest one in mathematics, number one is what we call a linear sequence. So that is a linear sequence, so which is also known as arithmetic progression. So AP, I'm going to cover that in the subsequent video. When we say it's linear sequence, so that is, such a sequence is obtained when the consecutive terms increase or decrease by adding or subtracting a constant number. Let's say, for example, if I have this type of number 1, 3, 5, 7, 9, and so on. So you will see that this type of number is an odd number, right? So, and it is a sequence because if it follows a pattern, the pattern it follows is by what? By adding 2 to the first term here, which is 1. So if you add 2 here, you are going to obtain 3. To obtain the next one, you add 2 again. You understand now? So since it follows a pattern or a rule, you can actually obtain the next term after 9 here. You know, for the next term after 9 here, that's going to give you what? 11. This one is going to give you 13. This one is going to give you what? So 15, and so on like that. You understand now? So that's an example of a sequence known as linear sequence. That is when the consecutive terms increase or decrease by what? By a constant number, and here which is what? Which is 2. That's an example of a linear sequence. You understand? So another example is nonlinear sequence. When we say a nonlinear sequence, is a type of sequence that are not linear. So they are not linear. The consecutive terms cannot increase or decrease by what? By a constant number. Let me give you an example. When you have something like this, I have 3, 9, 17, 27, 39. So this is also a sequence because it follows a certain pattern. you will see that the difference between the first two terms here is what? Is 6. The difference between this guy is 8. The difference between one is 10. You know, it follows a particular pattern. So it means you want to obtain this one, which is 12. To obtain the next one, it means you are going to add 14 to this. You understand that? So that's 39 plus 14. That will actually give you what? 53. So you understand now? So when you have a certain pattern like this, such that the difference between the two consecutive terms cannot give you, a constant term like we have here. So then you say it is a what? It's a nonlinear sequence. So then the third one, we have a geometric sequence. When we say a geometric sequence, is also known as, a GP, geometric progression, which I'm going to cover in the subsequent video. So, or an exponential sequence. It's a kind of rule such that the relationship between two consecutive terms is what? Is product. For example, when I have 2, 4, 8, 16. Yeah. You can see that this sequence actually follow a certain rule. For example, you will see that the relationship between what? Between the first two terms here is 2, that is multiplying, the first term by 2 to obtain the next one. So that's why if I say 2 times 2, I'm going to have 4. Then 4 times 2 is going to give me 8. This is an example of what? Geometric sequence. So you know you can obtain the next one here by multiplying 16 by 2. That will give you 32, 64, and so on and so forth. Then we still have what we call Fibonacci sequence. So when we say Fibonacci sequence, that is a type of sequence whereby each term is the summation of the two previous terms. For example, when I have 1 here, so you know it is like I'm having 0 here. You understand now? So when you say 0 plus 1, then I'm going to have 1. To obtain the next term, you add the two previous terms together. That is 1 plus 1, which is going to give you 2. To obtain the next one, you had two consecutive terms, which is 1 plus 2. That will give you 3. So the next time we give you 5. This one will give you 8. You see that they actually follow a what? A particular pattern. So when you have a sequence in terms of this pattern such that each term is the summation of what? Of two previous terms, then we call it what? A Fibonacci sequence. A Fibonacci sequence. Okay, now let's say, for example, this type of terms 1, 5, 7. You know, I'm giving the first 4 terms here. Assuming you want to find the 100th term now, are you going to be saying 7 plus 2, 9? Then you have 2. You know, if you're doing that, then you will stay there till tomorrow. You understand now? For example, if I ask you to find the what? 1 millionth term, so you will actually stop when you are tired. You can't finish it all. So, and that's why in mathematics we have to define somewhat. Some shortcut for us to what? To actually find this. So that's what we know as, the general term of a sequence. So the general term, so that is the nth term of a sequence. So if you are able to find the nth term of a sequence, then you should be able to find any term. So irrespective of the term or how larger the term is, you understand now? So the nth term of a sequence is just like a formula that's, enable you to find any term of your choice. Let me give you an example to understand what I'm trying to say. For example, the question says, write a formula for the nth term of the sequence 2, 6, 10, 14, 18. You have 2, 6, 10, 14, 18. Before I proceed, this what type of sequence with the example I gave before? You know it has a rule. You will see that the difference between the two consecutive terms is what? Is 4. The difference between this guy and this guy is 4. Between this guy and this guy is 4. So when the consecutive term increases or decreases by what? By a constant term, we call it what? A linear sequence. So how do you now find a general term of a general formula for the nth term of a linear sequence? It is not difficult to do. You can use any method of your choice. Just the main thing is to arrive at what? At the final answer. But the one I'm going to use for you is what? Is a kind of a tabular method. What you are going to do is to tabulate it first. You know we have how many terms here? 1, 2, 3, 4, 5. Then you can write the first 5 terms like it. Term 1, term 2, term 3, term 4, then term 5. You understand now? Then you have your term here. What is your term here? That is 2, 6, 10, 14, and 18. With what I explained before, you will observe that the difference between the two terms is what? You know, we have our difference here. The difference here is 4. The difference here is also 4. The difference between this guy and this guy is also 4. The difference between guy and this guy is also 4. Or let me say plus 4. You understand now? So that is 4, 4, 4, 4. What do you observe? You observe that when you have something in such a way that the difference between them is what? Is 4. When you have constant term like this, then it's just like your multiplication table 4. You understand? You know, for multiplication table 4, you know, 4 times 1, 4, 4 times 2, 8, 4 times, 3, that's 12. You can see it's also a sequence. And the constant term between the two consecutive term here is also 4. You know, it's just like the same pattern with it. But it's just that it doesn't follow the same pattern as this, the same way. But we can actually obtain this now. So by just checking or finding which number are we going to add to this guy, or we are going to subtract to this guy to actually form what we have here. And to do that is not difficult. What you can do is to what? You know, you have 4n, you can just say 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, that's what? 16. 4 times 5 is 20. You understand now? So the moment you obtain that, then you can actually find your Tn now. But before you go, just subtract, the general multiplication table, that is the sequence you have for multiplication table, subtract it from each of the corresponding terms here. For example, you just say 2 minus 4, that will give you minus 2, minus 2, 10 minus 12 minus 2. This also give you minus 2, minus 2. You understand now? Then you can conclude adequately that the nth term of this sequence, so we actually give you 4n minus 2. You understand now? And by giving this formula, you can actually obtain, your first term, second term, third term. Let's say I want to obtain my first term here. You know, my first term means when n is equal to 1. That is when you see n here, you substitute the value of 1. That will give you 4 times 1 minus 2, which is 4 times 1. 4 minus 2, that is 4. Let's say I want to find my fifth term here. You know, that will be 4 times 5, 20 minus 2, which is 18. You can see we have a formula now. So with this formula, you can actually find any terms of your choice. If you want to find the 100th formula, 100th term, you don't need to be writing it one by one. You can actually substitute the value of your n to be 100. So with this, we can actually solve the second question. The second question asks us to use the formula to obtain the 30th and 60th term of the sequence. 38th and 68th terms of the sequence. Okay, how do we do that? Since we know our formula, we know that my Tn is equal to 4n minus 2. So for me to find the 38th term, that is T30, meaning when you see n here, you substitute the value of what? The first value of 30, then I'm going to have 4 times 30 minus 2. So that is 120 minus 2. So if you subtract 120 from 2, I'm going to have what? 118. You can see it is very simple. You don't need to stress yourself by just doing it 120 times. You understand now? 30 term. Then the second one, we are asked to find the 60th term. Is that not so? Then your T60 means where you see n here, you substitute the value of 60. That will give me 4 times 60 minus 2. That's 240 minus 2, which gives me 238. Can you see it is very simple, is that not? Okay, now, let me give you another example to back it up to actually understand what I'm trying to do. Okay, now let's say example 2. Example 2. The question says, let me just place it here, sorry, so that you can actually see it very well. Yeah. Okay. So the question says the first 5 terms of a sequence are 100, 94, 88, 82, and 76. Then we have to find the formula for the nth term. Let me ask you first, is this a sequence or not? It is a sequence because if you check the terms very well, you notice that it follows a particular rule. And what is the rule? If you say this minus this, you are going to have minus 6. So you can say your term is like when you say second term minus first term, that will give you minus 6. This minus this will also give you minus 6. Minus 6. You understand now? And minus 6. In fact, this is what? It's a linear sequence because the difference between two consecutive terms actually give you negative 6. How are you going to do it? You follow the same approach like I've done the other time. Then here I'm going to have 1, 2, 3, 4, 5 since you were given the first 5 terms. Then after that, you can find your term. You insert your term. For the first term here, I have 100. To avoid mistake, you can actually do this. So then you have 94, you have 88, you have 82, you have 76. And like you've seen, the difference between the second and the first term is minus 6, which actually give you a constant minus 6, minus 6, minus 6. And what does this implies? It implies that you are actually working in what? A multiplication table minus 6. You understand that? And don't forget, by multiplication table minus 6, what you do is that minus 6 times 1 minus 6, minus 12, minus 18. You understand now? So it actually follows this pattern as well, just that it doesn't start from what? From 1. So but you can actually obtain what you are going to add to it or what you are going to subtract from it to actually give you the pattern that will generate this number. And don't forget, like I've explained in the first example, you don't need to stress yourself. What you are going to do is to what? Is to find your minus 6 n. That is, you multiply this by each of these number. Minus 6 times 1, that will give you minus 6, minus 12. Okay? Minus what? Minus 18, minus 24, and this is minus 30. You understand now? So if this is cleared, what are you going to do after this? Like I've explained the other time. So then what you are going to do is to what? Is to subtract this guy from this guy. That's what I did here. If you look up, let me show you again. Let me show you that again. Sorry, for the first example. Yeah. So you notice that after I generated the table here, what I did was to what? To subtract the number you were actually given your term from what? From the general multiplication table 4. So then you are going to do that for this guy as well. So what am I going to do? This is the term and this is the general term. Then you can actually subtract. That will give you 100 minus 6. That will give you 106. 94 minus, that is minus 90 minus plus. 94 plus 12 is also 106. You observe that you are going to have 106, 106, 106 for each of the what? So for each of the difference you are taking, then you can actually conclude that your Tn will be what? Don't forget I said this term, the general minus 6n plus the difference you are actually having. So plus 106. So with this one, I can use my formula to obtain the 38th n term of the sequence. How are you going to obtain that? Your T30 means wherever you see n, you put what? You substitute the value of 30. And that will give me what? Minus 180 plus 106. If you do that very well, you are going to have negative 74. And with this rule, you can actually obtain 1 million terms. In fact, you can obtain Ghafari's term. How do you obtain Ghafari's term? That will be minus 6 times Ghafari plus 106. So that's how you are going to find the general term of a linear sequence. So to conclude, let me give you another example. But for another example here now, when you have the terms to be non-linear, So how are you going to approach that? When your term is nonlinear, that's what I'm actually going to do here. Example 3. So for example 3, you have to write the formula for the nth term of the sequence 3, 9, 17, 27, 39. You understand now? Let's see, is it, a linear sequence? It's not a linear sequence because if you subtract this guy from this guy, this is 6. 17 minus 9 will give me 8. So this will also give me what? So this will give me 10. 27 minus 17, and this will give me 12. You can see you didn't obtain what? The general term. That's not a linear sequence. You didn't obtain a constant number. That's not a linear sequence. So, but it is what? It is a nonlinear sequence, and your nonlinear sequence can be in terms of a quadratic expression. The n term can be in terms of quadratic expression. You can see for the linear term, when we have our nth term is in terms of linear. When we say linear, that is when you have single power of n. For a nonlinear, you can have multiple power of n. That is, you can have your n squared. Then you have what? A quadratic what? A quadratic expression. So how do we approach this? If you want to do this, it is not difficult at all. Just obtain which term is it, which expression is this. We know it is not linear because it is not a single power of n. Is it a quadratic expression? So will it give us cubic expression? How do you obtain that? Then you still do another difference. So when you get to higher institution, for example, those of you want to study mathematics, you are going to do what? Your numerical analysis, you are going to do what we call forward difference and backward difference. So okay, now if you still subtract it, then this 8 minus 6 will give me 2. So this is also 2. 12 minus 10 is what? Sorry, excuse me. I think my pen is, yeah, let me just change it straight away. So 10 minus 8 is also 2. So 12 minus 10 is also 2. What do you observe? You observe that we now have the constant what? The constant term now, but at the second difference. So by implication, what that is explaining is that when you obtain your constant number at the first difference, that is linear term. When you obtain it at the second difference, that is known as what? So this is the first difference. When you obtain it at the second difference, so then you call this what? You call this a quadratic. Then it's going to give you a quadratic expression. You understand now? Let's say you didn't obtain, the constant number here, maybe after the third difference, D3. So then we are going to have a cubic expression. But since we obtain it at the second difference, we have a quadratic expression here. And this is known as what? Don't forget, when you say something is in quadratic expression, then the general form is what? Is of the form an squared plus bn plus c. You understand now? So you can actually obtain your a here, which is the coefficient of n squared here, by dividing what you have here by 2. Let's say your constant term is 6, you are going to divide 6 by 2. So then your a here will be 2 divided by 2. If your constant term here is 8, then you are going to say 8 divided by 2. So this will give you 1. You understand now? Since you have 1 now, then you mean that your 1n squared, you are going to obtain your 1n squared. Then you can as well use the table like I've actually explained the other time. Let me just draw the table so as to make it clearer. So we were also given what? How many terms? We were given the first 5 terms. Then you can also have your table like this. Your number of terms: 1, 2, 3, 4, 5. Understand? Then now I'm going to have what? So I'm going to have my your n square, 1n square. So for your 1n square, that is, you are going to obtain the general terms of it. You understand now? So if you do that, then what am I going to have? This is going to give me 1. 2 squared is 4. 3 squared is 9. This is 16. And this is 25. So, and this is 25. Then what are you going to do after that? Based on the explanation I gave. So, now after you've multiplied that and you obtain the general one, now you've actually know your n squared. You understand? So you actually know your n squared. So, but what you are going to do after that is to actually, so you have. Let me use. This is our n1 now. So you have your n2. That is when n is equal to 2. This is how I obtain it. That is, you square 2. That will actually give you what? That will actually give you 4. You understand now? So if you do this for this guy here, you are going to have what? You are going to have 9, you are going to have 16, you are going to have 25. So it means we've actually obtained this. How do we now obtain this Bn? How do you obtain this Bn? From what we've actually done before, from the first example, the difference between these two guys. If you check it very well, so this is what? This is actually 3. Or before you continue, this is you have the general term here and you have the number here. Let me write the number to make it clearer. I think we have 3, we have 9, 17. I want to use the same approach like we've used the other time. Okay, now let us subtract that. That will give me 2. So then this will give me 5, 8, 11, and 14. You understand now? Okay, now let us do this. Let us do subtract. It's just like we are trying to move backward. This is also a linear sequence. In fact, when you subtract this term from this term, you are going to have 3. 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 By implication, it means we can conclude adequately that this is what? We are working on multiplication table 3. You understand now? And don't forget what I did the other time. If you are working on multiplication table 3, then you have you start from 1. Then you can say this is 3, this is 6, this is 9, 12, 15. So the moment you obtain that, you can actually subtract what you have from what? So from this term here, from this sequence here, like we've done before, then this will give you 2 minus 3, that's minus 1, 5 minus 6, minus 1, minus 1. You will see that everything give you minus 1. Then you can conclude adequately that your constant is negative 1. Then the general term of this number, we know our a to be 1, then n squared. Then we know that our linear term from what we have here is what? 3n minus 1. Then it will give you 3n minus 1. So this is your general formula. From this general formula, you can actually obtain any of the term. For example, if I want to check whether I get it, maybe I want to obtain my first term, wherever you see 1, you put what? You put the value of, wherever you see n, you put the value of 1. That's give you 1 square plus 3 into 1 minus 1. That's 1 plus 3 minus 1. 1 plus 3 is 4. 4 minus 1 is 3. Can you see that now? Let's check for the second term too. That will give you T2, that is 2 square plus 3 into 2 minus 1. That's 4 plus 6 minus 1, which is 9. That's that. It is very simple. So that's that. What I've been doing so far is that I explain what is sequence. So that is the list of number that follow a certain rule. And I give you, special types of sequence we have, like linear, nonlinear, geometric, Fibonacci. So then after that, I explain how you can actually what? How you can actually obtain the general formula or nth term of what? Of a linear sequence or a nonlinear sequence. So if you actually understand this, then I encourage you to what? To go to your past question and solve what is related to this. In the next video, I'm going to meet you. But don't forget, if you've not subscribed to my channel yet, don't forget to do that, like, and share with your friends so that they benefit too. Till I meet you in the next video. Thank you.